polar asymptotes. Now, till now, you people have only seen this x coordinate and the y coordinates and points here can be found out by x and y coordinate only. Now, instead of this, suppose this is your this, and now you move in this direction or you move in this direction, whatever it is. The r changes, and the theta also changes. Or you may have a shape like this. Wait a minute. Yes, this way, and this way. This is a cardioid. It is very difficult. This is a cardioid. It is very difficult to find the xy equation for this. It's easier to tackle this with polar coordinates. See, you have seen xy coordinates in smaller classes. Now you will see r theta. R theta is known as polar coordinates. Polar, and this is Cartesian coordinates. They are both coordinate systems. This is polar coordinate system, and this is Cartesian coordinate system. छोटे क्लासेस में देखा होगा x और y कोऑर्डिनेट. अब देखोगे r और थीटा कोऑर्डिनेट. वैसे ये कार्डियोइड है, इसको ना x और y में डिफाइन करना बहुत मुश्किल होता है. इसको आसान पड़ता है r थीटा कोऑर्डिनेट में करने में. r थीटा के कोऑर्डिनेट में इसके इक्वेशन को एक्सप्रेस करना बहुत आसान पड़ता है. तो r थीटा एक कोऑर्डिनेट सिस्टम होता है जो कि प्लेन पे चलता है. उसकी r रेडियस चेंज होता है और थीटा चेंज हो सकता है. जैसे यहाँ पे हो रहा है, इसमें थीटा और r दोनों चेंज हो रहे हैं. इस वाले फिगर में थीटा और r दोनों चेंज हो रहे हैं. तो दिस इज कॉल्ड पोलर कोऑर्डिनेट्स. नाउ हाउ टू फाइंड पोलर asymptotes? The first point is you write 1 upon r is equal to f theta. Then second point, put f theta equal to 0. Find theta equal to theta 1, theta 2, and so on and so forth. Theta n like this. That means theta is equal to this is all that is. And third point is find f dash theta I. Find if f dash theta I varying from 1 to n. Whatever thetas you have found, you have to find for all of them. You have to find f dash theta I for all of them. Means you have to find f dash theta 1, f dash theta 2, f dash theta n. For all you have to find f dash theta 1 to theta n. Now if f dash theta 1 is equal to 0, then no asymptote for that. Wait a minute. No asymptote for that particular theta I. For that particular theta I. For that particular, suppose for f dash theta 1 is 0, then there is no asymptote for theta 1. For if f dash theta 5 is 0, theta 5, some different angle is 0, then there is no asymptote for that particular theta 5. Particular angle for the theta 5. Got the point? Now this, but if f dash theta I is not equal to 0, then the asymptote is given by asymptote is given by r sine theta minus theta I equal to 1 upon f dash theta I. Suppose f dash theta 1 is not 0. Then the asymptote is given by r sine theta minus theta 1 f dash theta 1 for that particular theta I. For that particular theta I. Let's do some examples in this. Then you will understand. Now the first question is r log a theta is equal to a. So 1 upon r is what? 1 upon r is log theta by a, and this is nothing but f theta. Put f theta equal to 0. That means 1 upon a log theta is equal to 0, and this is nothing but log 1. So therefore, just a minute. Instead of writing this way, wait a minute, is equal to 0. This implies log theta is equal to 0. Cross multiply this, and then you will get this. Log theta is equal to 0. This is equal to log 1. That means theta equal to 1. Now if theta is equal to 1, Now find f dash theta, f dash theta you find from here. From here you find f dash theta. F dash theta is 1 upon a theta. Log theta, the derivative of log theta is 1 upon theta. Now f dash 1 is 1 upon a into 1, nothing but 1 upon a, which is not equal to 0. Which is not equal to 0. Now therefore the asymptote is r sine theta minus 1 is equal to 1 upon f dash 1. So what is f dash 1? 1 upon a. Therefore r sine theta minus 1 is 1 upon 1 by a. This is nothing but r sine theta minus 1 is equal to a. This is the asymptote. Let us do 3 more questions. We will get the idea. Now let us write this thing. Question: r sine n theta equal to a. So 1 upon r is equal to sine n theta by a, and this is nothing but f theta. Put f theta equal to 0. Put f theta equal to 0 means sine n theta by a is equal to 0. That means sine n theta is equal to 0. That means sine n theta is equal to 0 means theta is equal to sine n theta. N theta is equal to sine k pi, where k belongs to integers. So 1 pi, sine, I told you na, sine pi, sine 2 pi, sine 3 pi, sine 4 pi are all 0. Sine 1 pi, 2 pi, 3 pi सारे 0 हो जाते हैं. Compare both of them. So n theta is k pi. From here you will get theta equal to k pi by n, where k belongs to integer. Now find f dash theta. F dash theta is n cos n theta by a. Now put in place of theta you put k pi. N cos n k pi by n whole divided by a. This n and this n cancels. So this becomes n cos k pi by a, where k belongs to integer. Now you know that cos k pi is always minus 1 to the power of k for k belonging to integer. Always. This is a known fact. Right? So f dash theta is this. Wait a minute. Here we are finding, wait a minute, I did it in a hurry. This is f dash k pi by n. This is actually this quantity. Let me rub this all. Let me make it a little bit more space. F dash, yes, this is f dash is n by a cos n theta. So f dash k pi by n is equal to this. So now this is f dash k pi by n, and this is nothing but this, and cos this is minus 1 to the power of k, which is never, so this is never 0. So this is so f dash k pi by n is equal to n by a minus 1 to the power of k, which is never equal to 0. Never 0. ये कभी भी 0 नहीं होता है. तो इसीलिए now your asymptote is r sine theta minus k pi by n is equal to 1 upon f dash. This is, you have to write this, f dash k pi by n, and this is nothing but, you may write it in two formats. See, so r sine theta minus k pi by n is equal to this, put this value So this will be 1 upon n cos k pi by a. This is nothing but a upon n cos k pi, and this is nothing but, oh sorry, not this bracket, here the bracket will be here, cos k pi by n, k pi by n, sorry, I missed out something here, that is, just a minute, let me rub this also, wait a minute, let me rub this also. This will be n by a cos k pi, right? Yes, cos k pi, that's right, cos k pi, I'm doing it right. So n by a is this. So this can be written as, if you want to write in this format, you can write this also in this format, that is 1 upon n by a minus 1 to the power of k. So this is when this will go up, so this will be r sine theta minus k pi. See, you can do it till here, let me rub this here, you can do it till here, you can finish यहाँ तक करके खत्म कर सकते हो, you can finish it here, or you may still, if you want to carry on, you can carry on and write a upon n minus 1 to the power of k, and this will become minus 1 to the power of minus k. If you take it up, a upon n, this will also do. You can finish it here only. Now see, this another question we have got, a good question. Question is r equal to a upon 1 minus cos theta. So 1 upon r is 1 minus cos theta upon a, and this is nothing but f theta. Put f theta equal to 0. So you have 1 minus cos theta by a equal to 0, implies 1 minus cos theta is equal to 0. That means cos theta equal to 1, and 1 means cos 2 k pi. K belongs to integer. This is some different k. This is also an integer. This k and that k is different. They are integers only. The notation, you can change the notation. Okay, you change the notation. Let's say n. This n and that n is different. This n is different. That is a particular n, and this is for all n. वहाँ पे जो पहले वाला क्वेश्चन किया था, वहाँ पे n एक particular n था. यहाँ पे n जो है वो integer है. नोटेशन है बस, वो कुछ नहीं है. जस्ट नोटेशन है. तो थीटा क्या हो गया? What is theta from here? What is theta? Theta is 2n pi. Now find f dash theta. F dash theta is nothing but, do it. 1 upon a is outside. Then you have 1. Wait a minute. What is f theta? F theta is 1 minus cos theta. Now find f dash theta. F dash theta is 1 upon a 0 plus sine theta. Because cos theta derivative is minus sine theta. So f dash theta is sine theta upon a, right? Upon a. Now f dash n theta. F dash n 2n pi. F dash 2n pi. I have to find, मुझे थीटा पे f dash देखना है. So let's put sine 2n pi by a, and sine 2 pi by n is always 0. So no asymptote in this case. कोई asymptote नहीं मिलेगा. क्यों? Sine pi, sine 2 pi, sine 3 pi, sine 4 pi, sine 6 pi, sine 7 pi सारे 0 होते हैं. तो sine 2n का मतलब क्या है? साइन जितने इवन नंबर है, साइन 2, साइन 4, साइन 6, साइन 8 सारे 0 हो जाएंगे. सो नो एसिम्प्टोट इन दिस प्लेस.